Hello everyone and welcome to my channel Statistics.Education. Today we are covering Karl Pearson's correlation coefficient. First of all, we will see some main formulas used in Karl Pearson method. After that, we'll learn about topics like covariance and standard deviation and also how to calculate them. And lastly, we will learn how to obtain correlation and how to interpret it. So without any further ado, let's begin the video. The Karl Pearson's correlation coefficient is represented by small r. Now here you can see six formulas and each of them is used to obtain Karl Pearson's correlation. Now I want you to write down all these six formulas in one page. So when you are solving the sum, you can always refer to that page and identify which formula to use. The first formula is R is equals to covariance of xy divided by standard deviation of x multiplied by standard deviation of y. Now this formula is known as fundamental formula or basic formula of Karl Pearson's method. Covariance and standard deviation can be found using two different formulas. Note them down and let's learn about what is covariance. First, let's look at these two graphs. One graph shows an upward trend suggesting a positive relationship, while the other shows a downward trend indicating a negative relationship. The direction of relationship can be visually understood from these graphs, but not in numerical terms. To obtain direction of relationship in numerical form, we use covariance. Covariance measures the direction of relationship in numerical form by calculating how much the deviations of two variables from their respective means correspond to each other. Now let's apply this formula to an example. So here we have the price of sugar as variable x and demand of the sugar in kilograms as variable y. Here, to obtain the deviations from the mean, first we need to obtain mean. To obtain mean, we need to total the values and divide it by the number of observations. So for x bar is equals to 720 divided by 5, that is 144. And for y bar is equals to 1915 divided by 5, that is 383. Now let's obtain the deviation. So for that we will prepare three more columns. First one is x minus x bar, the second one is y minus y bar, and the third one will be the product of these two. So that will be x minus x bar into y minus y bar, right? To obtain deviations, we will deduct the mean value from all the observations. So for x, it is 100 minus 144, that is minus 44. 120 minus 144, that is minus 24. And likewise for all the observations of variable x. The total of x minus x bar will always be 0. In some very rare cases, it may not be 0, but it most of the time it will be 0. And it will be very helpful to identify whether our calculation is right or wrong. So here it is 0, so it is correct. For y, it is 500 minus 383, that is 117. 425 minus 383, that is 42. And likewise for all the observations of y. Now here the y minus y bar is 0, so our calculation is correct. Now here I have showed all the calculation in this table, but while calculating the sum, you are not supposed to show all this subtraction. You can directly write the values, okay? Now for the last column, we will multiply x minus x bar into y minus y bar. So first value is minus 44 into 117, that will be minus 5148. The next value is minus 24 into 42, that is minus 1008, and so on for the rest of the values. And we will obtain sigma x minus x bar into y minus y bar, that is minus 11,460. Now we have prepared the table and we got all the values we need. So let's obtain covariance. Covariance of xy is equals to sigma x minus x bar into y minus y bar divided by n. Sigma x minus x bar into y minus y bar is minus 11,460 and number of observations are 5. So the answer will be minus 2,292. Here the value is negative, indicates there is a negative relationship between two variables. Now let's see how to interpret covariance. There are three types of interpretation. The first one is covariance is greater than 0. This indicates there is a positive relationship between two variables. The second one is covariance is less than 0. This indicates there is a negative relationship between two variables. And the third one is covariance equals to 0. This indicates there is no relationship between two variables. We have learned the first part of the correlation formula, that is covariance. Now we will learn the second part of the formula, that is standard deviation. Standard deviation. First of all, let's look at this graph and try to understand what it is suggesting. Here, the green dotted line indicates the deviation of each data points from the mean line, but we cannot get a numerical value from it. Thus, to obtain the spread of the data set in numerical form, we obtain standard deviation. Standard deviation measures the spread of data set in numerical form by calculating how much individual data points deviates from the overall mean of the data set. Note down this formula and let's see why this formula is used and how to solve sums using this formula. So we did prepare this table for covariance, right? Now here for both the variables x and y, we have already obtained the deviations, that is x minus x bar and y minus y bar. Now when we try to obtain the average deviations from these, here the total of both the columns is 0, right? So 0 divided by any number will result in 0. So this method will not work, right? Now to counter this, we use absolute measures in mean deviation or square of the deviations in standard deviation. So let's obtain the square of the deviations. Now before doing that, let me explain how this formula works. So here we are squaring the deviations because the original deviation cannot be averaged as the total is 0. So we are squaring it. Now we will total the square values and then we will obtain the average. But that average will be of squared version. Now we need to normalize it. So we will take out square root of it and thus standard deviation is equals to under root sigma x minus x bar square divided by n. Now let's obtain the square value for each variable. Now let me show you a shortcut trick for this. On your calculator, type what I say. So you will get the square values as well as the total at the same time. So first of all, minus 44 into m plus, minus 24 into m plus, 6 into m plus, 16 into m plus, 46 into m plus. Now press check button 3 times to get individual values and then press MRC button to get the total of the values, that is 4920. For y we will do the same thing, 117 into m plus, 42 into m plus, minus 3 into m plus, 63 into m plus, minus 93 into m plus. So we will press check button 3 times to obtain the values and then press MRC to obtain the total, that is 28,080. So we have obtained the values. Now let's obtain standard deviation using that. For x, the standard deviation is equals to under root sigma x minus x bar square upon n, that is under root 4920 divided by 5, and the final answer will be 31.3688. For y, standard deviation is equals to under root sigma y minus y bar square upon n, that is 28,080 divided by 5. So the final answer will be 74.94. Here, the higher standard deviation indicates the widely spread data, while the lower standard deviation indicates the data is less spread. So we have obtained the covariance, which is the top portion of the formula, and the standard deviation, which is the bottom portion of the formula. So we have all the values and knowledge to obtain correlation. R is equals to covariance of x and y divided by standard deviation of x multiplied by standard deviation of y. The covariance of xy is minus 2292 and the standard deviations are 31.3688 and 74.94. Here, when we multiply these both two, we will get 2350.7779. Now, when we divide these two, we will get the answer, that is minus 0.975, which is negative. So it indicates there is a negative correlation between two variables. Now let's take one more formula here before learning about how to interpret correlation. R is equals to sigma x minus x bar into y minus y bar divided by under root sigma x minus x bar square multiplied by under root sigma y minus y bar square. Here we have all the values. So sigma x minus x bar is equals to minus 11,460. Sigma x minus x bar square is 4920 and sigma y minus y bar square is 28,080. The square root values for both the variables are 70.1427 and 167.571. Now the product of these two will be 11,753.874. And when we divide these two, we'll get our final answer, that is minus 0.975. No matter which formula you use to obtain Karl Pearson's correlation coefficient, you will get the same answer. Now let's learn about how to interpret Karl Pearson's correlation coefficient. There are total 5 types of interpretations of Karl Pearson's correlation coefficient. Let's learn about each of them one by one. The first one is R is equals to plus 1. This indicates there is a perfect positive correlation between two variables. The next is R is equals to minus 1. This indicates there is a perfect negative correlation between two variables. The next is value of R is greater than 0 but less than 1. That is partially positive correlation. If the value of R is greater than 0.8 but less than 1, then there will be a strong relationship between two variables. If the value of R is greater than 0.3 but less than 0.8, then there will be a moderate relationship between two variables. And if the value of R is greater than 0 but less than 0.3, then there will be a weak relationship between two variables. The next is value of R is greater than minus 1 but less than 0. That is partially negative correlation. If the value of R is greater than minus 1 but less than minus 0.8, then there will be a strong relationship between two variables. If the value of R is greater than minus 0.8 but less than minus 0.3, then there will be a moderate relationship between two variables. And if the value of R is greater than minus 0.3 but less than 0, then there will be a weak relationship between two variables. And the last is R is equals to 0. This indicates the absence of relationship, means there is no relationship between two variables. For our example, the interpretation will be, here the value of R is minus 0.975, which indicates partially negative correlation. As the value of R is closer to minus 1, thus the relation is strong and it can be said that both the variables are closely related. Now try to solve these two sums on your own, and if you have any query, please feel free to add them into the comment section.